Our solar system holds secrets that defy every explanation. We think we know our cosmic neighborhood, yet strange and powerful mysteries lurk just next door. This journey explores 25 of the most baffling phenomena that challenge everything we understand about the planets, moons, and space around us. You will discover the truth behind signals from the void, vanishing objects, and storms that rage for centuries. We will uncover why a perfect geometric shape floats at Saturn's pole and what strange force may be tugging at our farthest spacecraft. By the end, you will see our solar system not as a map of solved puzzles, but as a realm of thrilling, unanswered questions. What cosmic riddle from our own backyard do you find most compelling? A single burst of radio energy tore through the cosmos in August 1977. It came from the direction of the constellation Sagittarius and lasted for 72 seconds. A powerful, focused signal that seemed to scream its artificial nature. The Big Ear Radio Telescope at Ohio State University recorded its intensity on a simple printout. When researcher Jerry Amon reviewed the data days later, he was so stunned by the perfect, expected signature of an interstellar transmission that he circled the alphanumeric code and wrote one word in the margin: "Wow." That single word named a mystery that has endured for nearly 5 decades. The signal was narrowband, meaning it was concentrated on one specific frequency, just as we would expect from an engineered broadcast. It faded in and out as the Earth's rotation swept the telescope's field of view across the sky, a clear sign it came from a fixed point in deep space. Yet, after that one brilliant shout, the signal never returned. Countless follow-up observations have scanned the same patch of sky, listening for a repeat, an echo, or any other clue. They have found only silence. All natural explanations, from a passing comet to a strange stellar event, have fallen short, unable to fully account for its unique properties. The WOW signal stands as a ghost in the machine, a one-time cosmic hello that arrived, was witnessed, and then vanished without a trace, leaving behind the haunting question of who or what was on the other end. That solitary signal from the void was not our first brush with cosmic pareidolia. Just 1 year before the WOW signal captivated listeners on Earth, a different kind of image was beamed back from the red planet, sparking a mystery carved in rock. In July of 1976, NASA Viking 1 orbiter was mapping the Cydonia region of Mars when it captured a photograph that would ignite imaginations for decades. The image showed what appeared to be a colossal human face, nearly 2 miles from end to end, staring up from the Martian desert, with shadowed eyes, a distinct nose, and a mouth set in a seemingly serene expression. The formation looked unmistakably like a monumental sculpture. The idea of an artifact from a lost Martian civilization instantly captured the public mind. It was a story written in the landscape itself, a silent sentinel waiting on a dead world. Scientists at the time were quick to suggest a more mundane explanation, a trick of light and angle on a natural mesa. But the seed was planted. For years, the face on Mars became a cultural icon, a cornerstone for theories of ancient aliens and lost histories, a symbol of the hidden secrets we might find on our neighboring world. Then, decades later, new technology delivered a verdict. Orbiters with powerful cameras, like Mars Global Surveyor, returned to Cydonia. They captured the formation from new angles and with stunning clarity, stripping away the shadows and the mystery. The high-resolution images revealed a battered, heavily eroded hill, a natural landform with no symmetry, no carved features, just the random scars of wind and time. The face had vanished, replaced by geology. Yet, the legend persists. The story of the face on Mars is less about a real alien artifact and more about our own profound desire to see ourselves in the cosmos, to find familiarity in the alien, and to believe that we are not alone in the vast, silent expanse. While our search for faces in the rocks has come up empty, the very air of Mars holds a far more tantalizing mystery. Methane gas ebbs and flows in the thin Martian atmosphere, a faint but potent signature that scientists have struggled to explain for years. Rovers like Curiosity have sniffed the air inside Gale Crater, recording sudden, dramatic spikes where methane concentrations skyrocket by a factor of 10, only to vanish back to undetectable levels within days. This is not a constant presence, but a sporadic and localized puff, as if the planet itself is exhaling secrets. On Earth, the vast majority of methane is produced by living organisms, from microbes to livestock, making its presence on Mars an immediate and thrilling clue in the search for life. Yet geology offers another possibility, as methane can also be released by subsurface chemical reactions between water, carbon dioxide, and certain types of rock. The puzzle is not just the gas itself, but its fleeting behavior. If the source were purely geological, like a slow, steady seep from underground reservoirs, we would expect to detect a more constant background level. The sharp spikes and rapid dissipation suggest an active, localized process that is either quickly destroying the gas or releasing it in sudden, unpredictable bursts. Is a hidden, subterranean biosphere occasionally venting its presence into the sky? Or is the red planet undergoing complex geological chemistry we do not yet understand? This atmospheric ghost refuses to be caught, making the hunt for its source one of the most urgent and compelling quests on Mars today. A sudden flash of fire brighter than the sun tore through the sky over Siberia on June 30th, 1908. Moments later, a shockwave of unimaginable force slammed into the remote Tunguska region, flattening 80 million trees across 800 square miles. The explosion was so powerful it registered on barometric sensors as far away as England, and the resulting atmospheric dust created nights so bright across Europe that people could read newspapers outdoors after midnight. Yet when investigators finally reached the remote site years later, they found no crater. The epicenter showed scorched, standing trees stripped of their branches, but no impact hole, no fragments of a meteorite, nothing but utter devastation without a clear cause. The leading theory suggests a small asteroid or comet, perhaps only 60 meters across, entered Earth's atmosphere at a shallow angle and detonated in a massive airburst several miles above the ground. The heat and pressure from the explosion instantly vaporized the object, leaving no large remnants behind, while the blast wave hammered the forest below like a cosmic fist. This airburst theory explains the lack of a crater, but the exact nature of the object remains a topic of debate. Was it a fragile icy comet that disintegrated easily, or a stony asteroid that shattered under immense pressure? More exotic ideas, though far less supported, have included a microscopic black hole passing through the planet, or even the explosion of an alien spacecraft, concepts born from the sheer strangeness of the event. Ultimately, Tunguska serves as a stark and sobering benchmark. It was a direct hit on an unpopulated area, but had it occurred just a few hours later, the rotation of the Earth would have placed it over a major European city, resulting in catastrophic loss of life. This single event, over a century old, fuels modern planetary defense studies, a constant reminder that our solar system is a dynamic shooting gallery and that our planet is not a silent observer, but an active target. Far beyond the orbit of Neptune, in the cold, dark fringes of our solar system, lies a ring of icy worlds known as the Kuiper Belt. Astronomers expected this vast reservoir of primordial debris to stretch on for billions of miles, a gradually thinning swarm of frozen objects left over from the solar system's birth. But when they began to map it, they found something deeply unsettling. The population of these distant icy bodies does not slowly fade away into the void. Instead, it plummets. At a distance of about 50 astronomical units from the Sun, the number of detected Kuiper Belt objects drops off a cliff. It is as if a cosmic construction crew put up a fence with a sign reading, "No objects beyond this point." This sudden and unexpected boundary defies our fundamental models of how planetary systems form. The primordial disk of dust and gas that birthed our planets should have distributed this material much farther out, creating a gentle slope, not a vertical wall. So what could have carved this abrupt edge? One compelling and thrilling possibility is the gravitational influence of a yet undiscovered planet. A massive world, several times the size of Earth, could be orbiting in the darkness far beyond the Kuiper Cliff. Its gravity would have shepherded the icy objects inward, clearing out a vast region of space and creating the sharp, unnatural border we observe today. This hypothetical Planet 9 would be the ghost in the machine, an unseen architect whose presence is inferred only by the empty space it has created. Alternatively, the cliff might be a fossil from a more violent past, a relic from a time when our sun was born in a dense cluster of stars. A close pass by a sibling star in that ancient nursery could have stripped away the outer Kuiper Belt, stealing its most distant members and leaving behind this stark frontier. The Kuiper Belt cliff is a silent witness to a story we are still learning to read, a boundary in the darkness that whispers of either a lost sibling star or a hidden world waiting to be found. Our own star holds a deep, ancient secret that rewrites the story of our beginnings. 4 billion years ago, our sun was a faint young star, radiating 30% less energy than it does today. According to every law of physics, the Earth and Mars should have been frozen, icy wastelands, their water locked in permanent global glaciers. Yet the geological record tells a completely different story. Ancient rocks on Earth show clear evidence of flowing rivers and vast oceans from that very time. On Mars, dry riverbeds and mineral deposits scream of a once warm and wet climate. This is the faint young sun paradox, a glaring contradiction between the cold sun our models demand and the warm, watery planets our evidence reveals. How could these worlds have been so hospitable under such a weak young star? The most popular solution points to a powerful planetary blanket, a thick atmosphere rich with greenhouse gases like methane and carbon dioxide could have trapped enough of the sun's feeble heat to keep the oceans liquid. But this idea has its own problems. For Earth, maintaining that greenhouse blanket for over 1 billion years is a complex balancing act. The geological cycle that regulates carbon dioxide would have had to work in perfect, delicate harmony, a stability that seems almost too good to be true. For Mars, the puzzle is even more profound. Even with a thick carbon dioxide atmosphere, climate models struggle to push temperatures above freezing across the entire planet. The red planet might have experienced brief, scorching warm spells from enormous volcanic eruptions or giant asteroid impacts, but these would have been fleeting, not the sustained period needed to carve its vast network of valleys. Could there be a missing ingredient we have not yet considered? A factor that fundamentally alters our understanding of planetary climate. This paradox forces us to question not just our past, but our future, reminding us that the delicate balance making a world habitable is far more mysterious than we ever imagined. This same sun, which once seemed too faint to warm our world, now illuminates a geometric perfection at Saturn that defies every expectation. At the planet's north pole, a perfect hexagon spins, a six-sided jet stream etched into the atmosphere with an almost artificial precision. This isn't a fleeting cloud formation. It has been raging for decades, perhaps for centuries, a colossal and stable storm system wider than two Earths. Imagine a hurricane so vast it could swallow our entire planet, then shape it into a polygon with razor-sharp edges, and set it spinning at the pole of a gas giant. That is the reality of Saturn's hexagon. It stands in stark contrast to the polar vortices we see on other worlds. Earth's Arctic winds swirl in a relatively chaotic, circular pattern. Even the vortex at Saturn's own south pole is a more familiar, though massive, circular hurricane. The northern hexagon is utterly unique, a feature with no known parallel in our solar system. What force could possibly sculpt a fluid atmosphere into such a rigid, geometric shape? The leading theory points to a phenomenon known as a standing wave. Deep within Saturn's churning atmosphere, giant jet streams race eastward at different speeds. Where these currents shear against one another, they can create a stable, repeating pattern of turbulence, much like the standing wave that forms behind a rock in a fast-moving stream. On Saturn, the scale is planetary, and the result is this six-sided behemoth. Computer simulations have successfully recreated hexagonal shapes by modeling these deep atmospheric currents, suggesting the answer lies buried in the hidden dynamics of the gas giant's interior. Yet the mystery is not fully solved. Why six sides? Why has this specific shape remained so locked in place for so long, immune to the chaotic weather that surrounds it? The hexagon is a cosmic puzzle box, a reminder that even the most familiar-looking planets can harbor structures of breathtaking and inexplicable order. While Saturn's hexagon is a fleeting atmospheric wonder, a far more permanent and distant structure exhibits a geometry just as perfect. Out in the depths of space, 2,300 light-years from Earth, hangs a cosmic object that looks less like a natural formation and more like a piece of divine architecture. Astronomers call it the Red Rectangle Nebula, a name that utterly fails to capture its breathtaking strangeness. Through powerful telescopes, it appears as a near-perfect X-shape, a pair of hollow, intersecting cones glowing with a deep crimson light. Etched within these cones are a series of evenly spaced, horizontal rungs, like the skeletal structure of a celestial ladder reaching into the void. This is not the chaotic, billowing cloud of a typical planetary nebula, the beautiful but messy death shroud of an average star. The red rectangle is a structure of impossible precision, a cosmic blueprint made real. The secret to its form lies at its very heart, a pair of stars locked in a tight gravitational dance. One of these stars is a dying red giant, shedding its outer layers into space. Normally, this expelled gas would expand in a roughly spherical shell, creating a simple, glowing bubble. But here, the second star intervenes. Its gravity pulls and focuses the outflowing material, funneling it into two opposing cones that form the iconic X shape we see from our vantage point. The rungs, those mysterious ladder steps, are thought to be periodic outbursts from the central star system, ejecting rings of dust that are then illuminated by the starlight. It is a slow, rhythmic death, one that writes its history in concentric circles of gas and dust. Yet, even this elegant explanation does not fully account for the nebula's stunning symmetry and the sharpness of its geometric lines. The red rectangle stands as a profound challenge to our models of stellar evolution, proving that the death of a star can be an act of breathtaking order, not just chaotic dispersal. It is a reminder that the universe often favors patterns we are only just beginning to perceive. While the geometric perfection of the red rectangle nebula hangs in distant space, a much closer mystery was unfolding right here in our own cosmic backyard. Decades ago, as the Pioneer 10 and Pioneer 11 spacecraft ventured beyond the planets, scientists began noticing something deeply wrong with their trajectories. These robotic explorers, the first human-made objects to travel into the outer solar system, were not where our best physics said they should be. A tiny, mysterious force was tugging them back, creating an almost imperceptible but constant deceleration toward the sun. This was the Pioneer anomaly, a ghostly pull that defied explanation for years. The effect was incredibly small, a deceleration smaller than a nanometer per second squared, a force so faint it was like a gentle breath on a sail from millions of miles away. Yet, over years and billions of miles of travel, this minuscule drag added up, creating a navigational discrepancy that grew to thousands of kilometers. For a long time, this unexplained force sparked wild theories. Was it evidence of a flaw in Einstein's theory of general relativity? Could it be the gravitational pull from some unseen, dark matter halo within our solar system? Or perhaps an entirely new force of physics acting on our spacecraft? The answer, when it finally came, was a testament to human ingenuity and the power of meticulous detective work. Scientists realized the culprit was not a new law of physics, but something far more mundane: heat. The spacecraft were powered by radioactive plutonium pellets, which generated electricity and, as a byproduct, a significant amount of waste heat. This heat radiated away from the spacecraft in all directions. However, because the spacecraft were designed with large dish antennas pointed back toward Earth, more heat was radiated from the back of the dish than from the front. This created a tiny but constant push, a photon rocket effect that acted as a perpetual brake, slowing the Pioneers down. The mystery was solved, but a subtle intrigue remains. When physicists painstakingly modeled every single watt of heat radiating from every component of the spacecraft, their calculations almost perfectly accounted for the observed deceleration. Almost a tiny sliver of the anomaly, a minuscule fraction of the effect, stubbornly remained unaccounted for. It is a whisper of a discrepancy, a hint that our understanding of thermal radiation in the deep, cold vacuum of space might still be ever so slightly incomplete. The Pioneer anomaly stands as a powerful lesson, showing us that sometimes the universe's greatest puzzles are not solved by discovering new physics, but by perfecting our understanding of the old. That ghostly pull on the Pioneer probes was a puzzle we ultimately solved with thermal physics, but another, far more massive gravitational mystery still haunts the outer darkness. Far beyond Neptune, a collection of small, icy worlds are dancing to a tune we cannot hear, their orbits orchestrated by an unseen conductor. These are the trans-Neptunian objects, frozen remnants from the solar system's birth, and their movements are not random. A handful of the most distant ones share a peculiar trait. Their elongated orbits are mysteriously clustered, all pointing in roughly the same direction and tilting in the same way. This is statistically bizarre, like finding a dozen scattered compass needles, all stubbornly pointing northeast instead of north. The odds of this happening by pure chance are astronomically low. Something must be hurting them, shaping their paths through gravitational influence. The most compelling explanation is a hidden giant, a planet several times more massive than Earth, orbiting so far from the Sun that it takes 10 to 20,000 years to complete a single, sluggish revolution. This hypothetical world, dubbed Planet 9, would act as a gravitational shepherd. Its immense pull, felt over millions of years, would have gathered these scattered objects and synchronized their orbits, forcing them into this strange and telling alignment. The search for this phantom planet is one of the great modern astronomical quests. Telescopes scan the predicted regions of sky, looking for a faint, slow-moving pinprick of light against the static backdrop of stars. Finding it is a monumental challenge, as its incredible distance means it would reflect very little sunlight, making it incredibly dim. Its orbit is also only loosely constrained, meaning astronomers must hunt across a sprawling celestial haystack. If it exists, Planet 9 would rewrite the story of our solar system's formation, suggesting a dramatic past where planets were scattered and rearranged. Its discovery would be a moment of profound humility and excitement, revealing that our cosmic neighborhood has always had a hidden giant, a silent, distant king we are only now learning to perceive. Just as the hunt for a hidden planet reshapes our outer solar system, a startling discovery closer to home has forced us to reimagine our nearest planetary neighbor. In the acidic, scorching skies of Venus, astronomers found a ghost of a molecule that should not be there. In September 2020, a team of researchers announced they had detected phosphine gas in the temperate cloud decks of our sister world. The announcement sent shockwaves through the scientific community, for on Earth, phosphine is a gas almost exclusively produced by life. It is manufactured by anaerobic bacteria thriving in oxygen-free environments like swamps and marshes, and even in the intestines of animals. Finding it in the atmosphere of Venus, a planet long considered a hellish, sterile wasteland, was like finding a candle flickering in a blast furnace. The gas was spotted in a specific layer of the Venusian atmosphere, about 30 to 40 miles above the surface, where the temperature and pressure are surprisingly Earth-like. This is the one and only place on Venus where some form of life, perhaps extremophile microbes, could theoretically survive, floating like aerial plankton in the thick, sulfuric clouds. The detection was not a direct observation of life, but a tantalizing clue, a potential biosignature that screamed the incredible possibility that we are not alone. Yet, science thrives on skepticism, and this discovery ignited a firestorm of debate. The initial data came from two powerful telescopes, the James Clerk Maxwell Telescope in Hawaii and the Atacama Large Millimeter Array in Chile. Other teams immediately reanalyzed the same data, questioning the methods. Could the signal be a misinterpretation? Was it actually sulfur dioxide, a common gas in the Venusian atmosphere, masquerading as phosphine? The initial team held firm, refining their analysis and insisting the phosphine signal was real. The controversy then shifted to a second, even more critical question. If the phosphine is real, what is producing it? Could there be a non-biological, abiotic process on Venus that we simply do not understand? Scientists scrambled to model every conceivable geological and chemical pathway. Could volcanic eruptions spew phosphorus-bearing rocks into the atmosphere where they react to form phosphine? Could lightning strikes or the intense solar wind trigger exotic chemical reactions? So far, every proposed abiotic explanation has fallen short, unable to account for the apparent abundance of the gas. The Venusian phosphine remains an enigma, a spectral line in a telescope's data that has split the scientific world in two. It is either a monumental discovery, the first real hint of life beyond Earth, or it is a testament to a complex and alien chemistry we have yet to decipher. Either way, this single molecule has resurrected Venus as a prime target in the search for life, transforming our sister planet from a forgotten inferno back into a world of profound and thrilling mystery. For centuries, sharp-eyed observers have witnessed our own moon betray a flicker of inner life. These are the transient lunar phenomena, brief and enigmatic flashes of light, strange colorations, and shifting patches of haze that appear and vanish without warning on the barren lunar surface. Astronomers, both amateur and professional, have logged thousands of these events, from sudden pinpricks of brilliance to glowing red patches that linger for hours. One of the most famous sightings came from the 18th century, when Sir William Herschel, the discoverer of Uranus, reported seeing several bright spots on the moon which he believed were volcanic eruptions. He even speculated that lunar inhabitants might be lighting great fires. In the modern era, these observations persist, unpredictable and maddeningly brief. So what could possibly be causing light shows on an airless, geologically dead world? The explanations range from the mundane to the profoundly mysterious. The simplest answer is meteoroid impacts. The moon has no atmosphere to protect it, so even a pebble-sized rock striking the surface at tens of thousands of miles per hour will vaporize in a flash of light, creating a tiny, temporary crater. These impact flashes are well documented and account for many of the quick star-like glimmers. A more intriguing possibility is outgassing. The moon's interior may still hold traces of radioactive elements, and as they decay, they generate heat. This heat could occasionally release trapped pockets of gas, like radon, which escape to the surface in a sudden plume. When this dust and gas are exposed to the raw vacuum of space and the unfiltered sunlight, they could theoretically glow or create a temporary hazy patch. Some scientists have even proposed triboluminescence, where the stress of the moon's crust, slowly cooling and shifting over billions of years, causes rocks to crack and generate tiny flashes of light from the built-up pressure. Yet, for every event that might be explained, others defy easy categorization. Why do some of these lights appear to move? Why do certain craters, like Aristarchus, seem to be hotspots for this activity, glowing with a peculiar frequency? The greatest challenge is their transient nature. By the time a large telescope is swung toward the reported location, the event is almost always over, leaving behind no evidence but a witness report. This makes them one of the most frustrating and compelling puzzles in lunar science. A reminder that even our closest celestial companion, a world we have walked upon, still holds onto its secrets, flickering in the darkness just beyond our reach. Deep in the unimaginable cold, a full light year from the sun, lies a ghost of our solar system's violent birth. The Oumuamua cloud is not a belt or a disk, but a vast, spherical shell of trillions of icy bodies, a cosmic reservoir of dormant comets enveloping our entire planetary neighborhood. Its existence defies simple logic. How did these primordial building blocks, which formed in the warm, dense disk close to the infant sun, end up stranded in the deepest, darkest freeze? The journey to this distant frontier was anything but gentle. In the solar system's chaotic first few million years, the newborn giant planets, Jupiter, Saturn, Uranus, and Neptune, acted like gravitational titans in a cosmic shooting gallery. Their immense gravity kicked and scattered countless icy planetesimals, hurling them in all directions. Some were flung completely out of the solar system, destined to wander the galaxy as rogue nomads. but others receive just enough of a push to send them on vast, elliptical orbits, reaching the very edge of the sun's gravitational influence. There, at the farthest possible point, the gentle tugs from passing stars and the Milky Way's own galactic tide work to circularize their paths, herding them into the immense spherical swarm we infer today. This explains the cloud's shape, a relic of that ancient chaos. Yet, there is another, even more dramatic layer to this story. Our sun was not born in isolation. It formed within a dense cluster of thousands of sibling stars, all packed relatively close together. In that stellar nursery, close encounters with other young suns would have been common. A passing star could have gravitationally plucked comets from the outer solar system, either stealing them outright or nudging them into the distant, stable orbits of the Oort cloud. This interstellar traffic would have been a key architect, helping to build this distant, icy fortress. The Oort cloud, therefore, is more than just a collection of frozen relics. It is a fossilized record of our solar system's most tumultuous early days, a permanent monument to the gravitational storms that raged as the planets were born, and a signature of the long-lost stellar siblings we have not seen for billions of years. Far out in the constellation Cygnus, a star began to misbehave. Known as KIC 8462852, or Tabby's star, it was being monitored by the Kepler Space Telescope, an instrument designed to find planets by the telltale, rhythmic dimming they cause as they cross their star's face. But this star's light curve was unlike anything ever seen. Instead of the gentle, periodic dips of an orbiting planet, the star's light would plummet erratically, sometimes by a staggering 22%. A planet the size of Jupiter would block only about 1% of a sun-like star's light. Whatever was passing in front of Tabby's star was colossal, blotting out a massive portion of its glow in jagged, unpredictable patterns. The dips lasted for days or weeks, with no discernible rhythm, as if a swarm of enormous, irregular shapes were endlessly circling the star. The strangeness was so profound that astronomers struggled for a natural explanation. The leading hypothesis, a cloud of cometary debris, seemed strained. To block that much light, it would require an unimaginable number of comets, hundreds of thousands, all swarming in a tight, chaotic cluster. The sheer scale of such a swarm defied belief. It was this utter lack of a convincing natural model that opened the door to a breathtaking, if speculative, possibility. Could this be evidence of an alien megastructure? The idea, first proposed by astronomer Jason Wright, was that an advanced civilization might be building a Dyson swarm, a vast collection of energy-collecting panels orbiting their star to harness its total power output. Such a structure would be irregular, blocking light in the bizarre, aperiodic way that Tabby's star exhibited. For a moment, we were faced with the tantalizing thought that we might have stumbled upon the signature of intelligence on a scale beyond human comprehension. Yet, science demands evidence, not just wonder. Follow-up observations across the electromagnetic spectrum revealed a critical clue. The star dimmed more in some wavelengths, like blue and ultraviolet light, than it did in others, like infrared. This was the fingerprint of dust. Solid objects, like a megastructure made of metal and rock, would block all wavelengths of light equally. Dust, however, is made of tiny particles that scatter shorter wavelengths more effectively, creating the exact kind of wavelength-dependent dimming that was observed. The current consensus now points away from alien engineering and toward a complex, natural, and still deeply mysterious dust cloud, likely from a disrupted moon or a vast family of exocomets undergoing a period of catastrophic collisions. Yet, even this explanation leaves questions. What event could shatter a world on such a scale? How can a dust cloud remain stable enough to cause these dramatic, multi-year dimming events? Tabby's star remains an enigma, a cosmic reminder that nature's imagination often far surpasses our own, capable of producing phenomena so strange they briefly let us dream of builders among the stars. Even as we search the skies for alien structures, our own spacecraft have stumbled upon a rain of invisible bullets from the void. Far beyond the planets, the Voyager probes, now drifting in interstellar space, have detected a strange and relentless downpour of high-energy cosmic rays. These are not the gentle, low-energy particles that stream from our sun, but atomic nuclei accelerated to nearly the speed of light, each one a microscopic cannonball of immense power. The real mystery began when scientists cataloged their energy levels, expecting a predictable decline in the number of the most powerful rays. Instead, they found an excess, a surprising surplus of these ultra-high energy particles that our current models cannot fully explain. For decades, we thought we knew their primary source. Supernova, the violent deaths of massive stars, were the perfect cosmic accelerators. Their expanding shock waves were thought to sling charged particles across the galaxy, creating the diffuse background sea of cosmic rays we routinely detect. But the anomalous excess spotted by Voyager and, closer to home, by the Alpha Magnetic Spectrometer on the International Space Station, tells a different story. This is not the uniform spray from distant stellar explosions. This is something else, something more local and perhaps more exotic. What could be firing these atomic bullets at us from somewhere in our galactic neighborhood? The leading suspects are closer and more dramatic than we imagined. A nearby supernova remnant, the expanding shell of a star that died perhaps only a few million years ago, could be the culprit, its shockwaves still actively pumping particles in our direction. Or perhaps the source is a pulsar, the rapidly spinning, magnetized corpse of a star, acting like a colossal natural particle accelerator. There is even the speculative possibility that these rays are the signature of dark matter, the elusive substance that makes up most of the universe's mass. When two particles of dark matter theoretically collide, they could annihilate and produce a shower of standard particles, including the very high-energy cosmic rays we are now detecting. Each of these explanations would rewrite a chapter of our local cosmic history. A nearby supernova remnant would mean we are living in the aftermath of a recent titanic explosion. A pulsar would point to a powerful, unseen engine humming in the darkness just a few hundred light-years away. And if the source is dark matter, it would be our first tangible clue to the nature of this shadow component of the universe, caught in the act of revealing itself. This anomalous rain is more than a scientific curiosity. It is a message, written in the language of atomic nuclei, telling us that our galactic backyard holds energetic phenomena we have only just begun to sense. Even the farthest things we can see are caught in a current we cannot explain. Across the observable universe, enormous clusters of galaxies, each containing thousands of stellar systems, appear to be streaming in a coordinated direction. This is the dark flow, a mysterious and controversial drift on a scale so vast it defies our understanding of cosmic structure. These clusters are not just expanding with the universe, they are moving with a surprising additional velocity, all pulled toward a single point in the distant sky, as if by a cosmic tide. The force required to move such immense structures is beyond comprehension, and the source cannot be anything within our known universe. The leading and most staggering explanation is that this flow is the gravitational pull from something entirely outside our cosmic horizon, a massive structure in the unobservable universe beyond the reach of our telescopes. It could be the imprint of another universe, a sibling bubble in the greater multiverse, whose gravity is somehow leaking into our own. Or it might be the remnant of a violent pre-Big Bang event, a wrinkle in spacetime that set this current in motion eons ago. The very idea challenges the cosmological principle, a foundational tenet of astronomy which states that the universe should be roughly the same in all directions when viewed on a large enough scale. The dark flow suggests it might not be, yet the finding is hotly debated. Other teams analyzing different datasets have failed to detect the flow, arguing it could be a subtle systematic error in the original observations. The controversy itself highlights the cutting edge of cosmology, where the faintest signals at the very limits of detection could either reveal a new layer of reality or simply vanish under closer scrutiny. This great cosmic river, if it is real, points toward a reality far grander than we ever imagined, hinting that our entire observable universe is but a single leaf, floating on a current whose source lies in an unseen ocean. Saturn's rings reveal their secrets through fleeting disturbances. Etched within the brilliant bands of ice are thousands of ghostly features known as propellers, strange S-shaped voids that appear, move, and fade within the countless ring particles. These are the signatures of unseen moonlets, tiny worlds no larger than a kilometer across, embedded within the ring plane itself. Each propeller is a gravitational wake, created as one of these hidden moonlets plows through the ring material, its gravity clearing a temporary path like a cosmic icebreaker sailing through a frozen sea. The Cassini spacecraft captured these enigmatic forms in stunning detail, revealing a dynamic, living system where miniature worlds are constantly being born and reshaped. This leads to a profound and active puzzle. How do these moonlets form in the first place, and what guides their journey? The rings are unimaginably thin, often no thicker than a two-story building, yet they are wide enough to span the gap between the Earth and the Moon. Within this vast, flat sheet of ice and dust, gravity encourages particles to clump together. A small, dense chunk of ice might act as a seed, slowly accumulating a coat of ring material until it grows large enough for its own gravity to take over, clearing its immediate vicinity and becoming a true, albeit tiny, moon. But the story does not end with their birth. Observations show that these propellers are migrating, drifting slowly through the rings over time. This movement is the real heart of the mystery. A moonlet should, in theory, follow a simple, predictable orbit dictated by Saturn's immense gravity. Yet something is nudging them, causing their paths to change. The leading suspect is a complex gravitational dance with the ring particles themselves, and with Saturn's larger, more established moons. Just as the moon's gravity tugs at our oceans to create tides, these small moonlets feel the pull of their massive siblings. This interaction can create waves within the ring material that, in turn, exert a gentle but constant pressure back on the moonlet, slowly pushing it inward or outward over millions of years. It is a delicate feedback loop between a hidden world and the disk that cradles it. These tiny propellers offer a stunning glimpse into the processes that may have built the giant planets themselves. A miniature laboratory for planet formation happening right before our eyes. A silent, elegant ballet of gravity and ice unfolding within Saturn's brilliant rings. This colossal storm is a vortex of fury wider than our entire planet. A hurricane that has raged for at least 350 years. Since the first telescopes of the 17th century gave us a clear view of Jupiter, the great red spot has been there, a churning, brick-red eye in the southern hemisphere of the gas giant. It spins counterclockwise, completing a full rotation about once every 6 Earth days. An island of stability in a chaotic, multicolored sea of cloud bands and smaller, fleeting storms. The fundamental mystery is one of endurance. How can a storm of this magnitude survive for centuries when even the most powerful hurricanes on Earth dissipate after a few weeks over the ocean? The answer lies in the alien nature of Jupiter itself. Our planet has a solid surface, and when a hurricane moves over land, it is starved of its warm, moist fuel and quickly falls apart. The Great Red Spot has no such obstacle. Jupiter is a fluid world, a ball of hydrogen and helium with no solid ground to disrupt the storm's flow. It is a self-sustaining atmospheric engine, feeding on the smaller storms and turbulent eddies that it constantly absorbs. The spot acts like a giant gear in Jupiter's weather machine, powered by the planet's immense internal heat, which rises from its core and creates powerful vertical wind currents that continually reinvigorate the storm, preventing it from ever truly running out of energy. Yet, even this ancient titan is showing signs of age. For over a century, astronomers have been tracking its dimensions, and the data reveals a slow but steady decline. The storm that was once wide enough to swallow 3 Earths side by side is now barely larger than one. Its shape is changing too, becoming more circular than oval, as if it is slowly losing its grip. Some scientists believe this is part of a natural, long-term cycle of contraction and expansion, while others worry it might be a sign of the storm's final, slow death. Recent observations add another layer of intrigue, showing that as the spot shrinks, it is also intensifying, its winds speeding up and its color deepening to a more vibrant orange-red. Is this the storm's last defiant stand, growing stronger and more concentrated as it fades in size? Or is it simply transforming into a new, equally mysterious phase of its immortal life? This enduring tempest is a testament to the sheer power of planetary forces we are only beginning to understand. A whirlwind that has witnessed centuries of human history from 500 million miles away, and its final chapter has yet to be written. While Jupiter's great storm is bound to its star, other worlds travel in absolute freedom, completely untethered from any sun. These are the rogue planets, dark nomads wandering the interstellar void. For a long time, they were only a theoretical possibility, but we now know these solitary worlds are real, and they might even outnumber the stars in our galaxy. Imagine a planet like Jupiter or even Earth, but one that does not circle a star. It exists in perpetual night, a frozen, lonely globe drifting through an endless sea of blackness. Its surface, if it has one, would be a landscape of profound cold, where any atmosphere has long since frozen solid, and the only light comes from the distant, unmoving pinpricks of the galaxy's stars. How does a world end up so utterly alone? The most common path is a violent ejection. In a young solar system, planets are jostling for position, their orbits not yet settled. A close gravitational encounter between 2 giant planets can be catastrophic. One world might slingshot the other, flinging it with such force that it breaks free from its star's gravity entirely, cast out in the galactic wilderness. This is not a rare event. Models suggest that our own solar system may have ejected several such worlds in its tumultuous youth. Some rogue planets might never have known a sun at all, forming not in a disk around a star, but from the direct collapse of a small, isolated cloud of gas and dust, a failed star that never gathered enough mass to ignite. Detecting these dark wanderers is one of astronomy's greatest challenges. They emit no light of their own and reflect none. We find them through a cosmic quirk of gravity known as microlensing. When a rogue planet passes directly between us and a distant background star, Its gravity acts as a lens, bending and briefly magnifying the star's light. For a few hours or days, the star appears to brighten in a specific, telltale way before fading back to normal. This fleeting signal is our only window into this hidden population. Each detection is a monumental achievement, a ghost caught in the act of crossing our path. The existence of these solitary worlds expands our understanding of planet formation to its absolute limits and raises a haunting question. Could a rocky, Earth-sized rogue planet, ejected from its cozy orbit, somehow retain a subsurface ocean kept liquid by geothermal heat, a dark, isolated abyss where life clings to existence far from any star? It is a profound thought that the most common habitable environments in the galaxy might not be in the light, but in the eternal, frozen dark between the stars. Deep within the asteroid belt, a dwarf planet holds a secret of brilliant, impossible light. When the Dawn spacecraft approached Ceres, it saw a world of dark, cratered rock, but one crater, Achater, blazed with a cluster of dazzling spots so bright they defied all expectation. These were not the gentle reflections of ice, but searingly bright beacons standing in stark contrast to the charcoal gray terrain around them. What could possibly be so reflective on this small, cold world? The answer proved to be just as strange as the spots themselves. They are vast deposits of sodium carbonate, a gleaming, salt-like substance commonly found on Earth in places like dried-up lake beds. Seeing it on Ceres was a monumental surprise, as this material typically requires liquid water to form. It is the ghost of an ancient ocean, a chemical signature of a watery past. The central mystery now is how this salty residue came to be exposed in such a brilliant, concentrated form. The leading theory paints a dramatic picture. Scientists believe Ceres might harbor a deep, subsurface reservoir of briny water, a hidden ocean lingering beneath its rocky crust. In the distant past, a massive impact created the Achater crater, fracturing the crust all the way down to this buried reservoir. This allowed the salty brine to surge upward, gushing out onto the crater floor where it quickly froze, and then, over millions of years, the water ice slowly sublimated away, vanishing into the vacuum of space. This process left behind only the brilliant, refractory salts, a gleaming bathtub ring marking where an ancient sea once briefly breached the surface. But not everyone is convinced this was a one-time event. An alternative and equally thrilling idea suggests that Ceres is not entirely dead geologically. Could residual heat from the dwarf planet's interior still be warming that deep brine, causing occasional, lingering eruptions? This would mean the bright spots are not a static monument, but an active process, with salty slush occasionally percolating up from the depths to refresh the brilliant deposits even today. The difference is profound. Is Achater crater a frozen tomb for a long-lost ocean? Or is it a window into a still living, slushy world? A place where chemistry and potential habitability might still be stirring in the dark. These gleaming spots on a tiny world remind us that water, the essential ingredient for life as we know it, can find a home in the most unexpected of places, turning a simple dwarf planet into one of the most intriguing targets in our entire solar system. That hidden ocean within Ceres suggests our solar system is far from isolated, a notion proven by the sudden arrival of uninvited guests from the vast spaces between the stars. In October 2017, astronomers in Hawaii spotted a strange object speeding away from the sun. It was named Oumuamua, a Hawaiian word for a scout or messenger from the distant past. Calculations of its trajectory were immediate and shocking, This was not a comet or asteroid from our own solar system. It was the first object ever detected that had come from interstellar space, a visitor from another star. Its physical properties were even more baffling. Based on its changing brightness, scientists deduced its shape was extreme, a cigar or pancake-like object at least 10 times longer than it was wide, tumbling end over end through space. Nothing in our solar system has such a pronounced, elongated form. Then came the real puzzle, its motion. As Oumuamua hurtled away from the sun, it was not following a simple path dictated by gravity alone. It was accelerating, speeding up in a way that could not be explained by the pull of the sun or planets. For a comet, this would be normal. The heat of the sun vaporizes ice on its surface, creating a jet of gas that acts like a natural rocket engine. But Oumuamua showed no visible coma, no tail of gas and dust, no signature of outgassing at all. It was as dark and inert as a chunk of rock, yet something was pushing it. This acceleration sparked a firestorm of scientific debate and public imagination. Was it a hydrogen iceberg, a type of object never seen before, slowly shedding invisible hydrogen gas? Was it a dust bunny, an ultra-low-density fractal object that sunlight itself could push like a solar sail? Or, as one prominent astronomer suggested, could it be a piece of alien technology, a light sail from a long-dead civilization? While the extraterrestrial hypothesis captured headlines, the scientific consensus has since leaned toward a natural, if extraordinary, explanation. The leading idea is that Oumuamua was indeed a comet, but a very ancient and strange one. After eons of exposure to cosmic radiation, its outer layers could have developed a thick, insulating crust, trapping volatile ices within. When the sun warmed it, those ices could have turned to gas and seeped out through tiny, unseen jets, providing the thrust without producing a visible tail, a stealthy form of propulsion from a deeply exotic object. Just 2 years later, a second visitor arrived, Comet 2I Borisov. This object was far more familiar, a classic icy comet with a brilliant tail of gas and dust, behaving exactly as scientists would expect. Its normalcy was, in its own way, just as profound as Oumuamua's strangeness. It proved that Oumuamua was not a fluke, that interstellar objects are common, and that other planetary systems form and fling out material in ways both familiar and bizarre. Together, these two scouts reveal our solar system is not a closed ecosystem. We are part of a dynamic galactic environment, constantly exchanging material with our stellar neighbors, and the next strange visitor could arrive at any moment, carrying with it the untold secrets of a star system we will never see. The sun's surface simmers at a temperature of around 10,000 degrees Fahrenheit, a heat so intense it can vaporize rock and metal. Yet, if you rise up into the wispy, pearly white outer atmosphere, the corona, the temperature soars to millions of degrees. This is the solar corona heating problem, a fundamental paradox that has puzzled scientists for decades. How can the sun's atmosphere be hundreds of times hotter than the surface it surrounds? It defies basic intuition, like walking away from a fire and feeling the air get blisteringly hotter instead of colder. The energy must be coming from somewhere, transferred from the relatively cool surface up into the superheated corona. The leading suspect is the sun's own magnetic field, a tangled, dynamic web of invisible forces that threads through the solar plasma. Two primary theories compete to explain how this magnetic energy cooks the corona. The first involves an unceasing storm of tiny explosions called nanoflares. These are not the massive solar flares that disrupt communications on Earth, but countless, minuscule counterparts. Each nanoflare releases a burst of energy as magnetic field lines snap and reconnect, a process similar to the sudden release of a twisted rubber band. Individually, they are too small for our instruments to detect directly, but collectively, this endless, invisible bombardment could provide the steady heat that keeps the corona at its incredible temperature. The second theory points to magnetic waves. The sun's surface is a constant roil of convection, like a pot of boiling water, and this motion sends powerful waves racing along the magnetic field lines up into the corona. As these waves travel, they can transform their energy of motion into intense heat, much like how sound waves can generate warmth when they are focused. The challenge is that both processes are likely happening simultaneously, and scientists are still trying to determine which one is the dominant chef in this cosmic kitchen. Solving this mystery is not just an academic exercise. The corona is the source of the solar wind, a stream of charged particles that flows throughout the solar system, creating space weather that can threaten satellites and power grids. Understanding how it is heated is the key to predicting the sun's violent moods, a reminder that the greatest secrets of our solar system are often hidden in the most brilliant and obvious of places. Our solar system's orderly dance of planets hides a history of incredible violence. While most worlds spin like tops as they orbit the Sun, two giants, Uranus and Neptune, have been knocked completely askew. Uranus is the true oddity, tilted a staggering 98 degrees, essentially rolling on its side around the Sun. This gives it the most extreme seasons in the solar system, where for 21-year stretches, one pole is bathed in constant sunlight while the other is locked in utter darkness. Neptune, while less extreme with a tilt of about 28 degrees, still spins at a sharp angle compared to a planet like Earth. How did these colossal worlds get thrown so dramatically off kilter? The leading explanation points to a cataclysm in the solar system's youth, a time of chaotic orbital migrations and colossal impacts. For Uranus, the prevailing theory is a direct, shattering collision with an object roughly the size of Earth. This was not a glancing blow, but a head-on impact so powerful it literally knocked the entire planet over, reorienting its spin axis and leaving it to roll through the cosmos. A hit of that magnitude would have also vaporized a tremendous amount of material, which could have then coalesced to form the planet's system of rings and moons, all orbiting perfectly in the new tilted plane. This single, ancient catastrophe could explain the entire bizarre configuration we see today. Yet, this dramatic answer raises new and troubling questions. If a single impact knocked Uranus over, why does Neptune also have a significant tilt? Did it, too, suffer a similar colossal crash? Having two separate Earth-sized impacts in the outer solar system stretches the probabilities, making it a less elegant solution. This has led to an alternative idea, one involving gravitational chaos. As the giant planets jostled for position billions of years ago, their complex gravitational dances could have induced wild wobbles in each other's spins, potentially tilting them without the need for a direct impact. The problem is that current models struggle to reproduce the precise, extreme tilt of Uranus through gravitational interactions alone. So we are left with a cosmic crime scene, billions of years cold. The impact theory fits the evidence for Uranus beautifully, but it feels almost too perfectly catastrophic. The gravitational theory is more subtle, but it cannot yet account for the sheer scale of the tilt. The lingering mystery of these tilted giants is a stark reminder that the serene order we see in the solar system today was forged in an era of unimaginable chaos and violence. the echoes of which are still written in the awkward spin of a world forever on its side. These ghostly patterns are painted in light upon the lunar surface. Across the dark plains of the moon, vast, swirling formations of brilliant, almost white material curl and loop for hundreds of miles, looking like cosmic fingerprints pressed in the dust. One of the most prominent Reiner Gamma resembles a delicate, swirling vortex, a stark, bright splash against the darker mare around it. For decades, these lunar swirls presented a dual mystery, their beautiful form and their puzzling resistance to change. The moon is constantly bombarded by solar wind and micrometeorites, a process called space weathering that steadily darkens the surface, turning fresh, bright soil into a dim, charcoal gray over millions of years. Yet these swirls remain brilliantly reflective, as if they were painted yesterday. The key to their preservation appears to be magnetism. When orbiting probes mapped the lunar magnetic fields, they discovered something remarkable. Each of these bright swirls sits directly above a powerful, localized magnetic anomaly. These are not global fields like Earth's, but isolated bubbles of magnetism embedded in the lunar crust, creating miniature magnetic shields. The leading theory suggests that these magnetic bubbles deflect the relentless stream of solar wind particles. Since the solar wind is a primary agent of darkening, the protected soil within the swirl remains bright, while the surrounding, unprotected terrain slowly weathers and darkens. This creates the stunning, high-contrast patterns we see. But this elegant explanation only deepens the central puzzle. What created these magnetic anomalies in the first place? The moon has no global magnetic field today, so these localized, powerful magnets are fossils, relics of a more magnetic past. One compelling idea points to cometary impacts. The theory proposes that when a comet struck the moon, the immense heat and pressure of the impact melted the crust, which contained iron-rich minerals. As this molten rock cooled in the presence of a temporary, impact-generated magnetic field, the iron particles aligned, permanently recording that moment of violence like a cosmic tape recorder. The resulting magnetic rock now shields the surface. Another, more speculative theory wonders if the swirls and the magnets are both the product of subsurface lava tubes, long since collapsed, whose unique mineral composition generates both the magnetism and the bright material. The true origin remains just out of reach, a beautiful, silent riddle written in light and stone, a reminder that even our closest neighbor keeps its most artistic secrets locked away. The solar system's gravitational dance carves out pockets of perfect stability, yet some of these cosmic safe havens remain strangely vacant, while other planets have crowds of ancient rocks huddled in their orbital nurseries. Earth's most stable points are eerily quiet. These are the Lagrange points, 5 specific positions in space where the gravitational pulls of the Earth and the Sun balance perfectly with the orbital motion of any object placed there. Points L4 and L5, positioned 60 degrees ahead of and behind our planet in its orbit, are particularly stable, acting like gravitational bowls where objects can be trapped for eons. For Jupiter, these points are teeming with thousands of Trojan asteroids, a fossilized record of the early solar system. Mars and Neptune have their own families of Trojans. But Earth's L4 and L5 points are, for the most part, empty. We have found only one tiny, temporary Trojan, a small asteroid that seems to be a recent visitor rather than a permanent resident. This cosmic silence is a puzzle. Why are our most stable parking spots so deserted? The answer may lie in the unique gravitational turmoil of our inner solar system. Earth orbits in a dynamic, crowded neighborhood, constantly jostled by the gravitational influences of Venus and Mars. These nearby worlds create subtle but persistent tugs, like gentle but relentless currents in a cosmic sea. Over millions of years, these perturbations can destabilize objects trying to reside at our Lagrange points, slowly nudging them out of their stable bowls and sending them on new paths, either to collide with a planet or be ejected from the inner system entirely. Another possibility points to a more violent past. The late heavy bombardment, a period about 4 billion years ago when the inner planets were pummeled by a hail of asteroids and comets, might have scoured our Lagrange points clean. Any primordial Trojans that gathered there in the solar system's youth could have been blasted away in that ancient cataclysm, leaving our orbital guardianship starkly empty. This emptiness is not just a curiosity, it is a clue. The void at L4 and L5 speaks volumes about the chaotic and violent history that shaped our planetary system, a quiet testament to the gravitational storms that have long since calmed, leaving behind a mystery written in nothingness. From the ghostly whisper of the WOW signal to the silent drift of interstellar nomads, these 25 cosmic puzzles paint a portrait of a solar system brimming with enigma. We have wandered through storms that outlive civilizations, gazed upon geometric perfection carved into gas and light, and chased the gravitational ghosts of hidden worlds. Each mystery, from the faint young sun that defied climate models to the hidden ocean on a dwarf planet, chips away at our certainty, reminding us that our cosmic backyard is a realm of profound and thrilling unknowns. The greatest lesson from this journey is not a list of answers, but a humbling recognition of the vast frontiers of our ignorance. We have only just begun to listen, to look, and to understand the dynamic, chaotic, and beautiful system we call home. So tell us, as you reflect on these 25 riddles, which one captured your imagination most profoundly? Was it the enduring fury of Jupiter's great red spot, the haunting possibility of phosphine on Venus, or the silent, empty Lagrange points guarding Earth's orbit? Share your thoughts in the comments below, and let's continue this exploration of the cosmos together.